Welcome to this brief screencast on the next step of arrays. We're going to talk about how to process arrays and looping over arrays and and some of the built-in growing an array, making it larger and smaller. So often we want to loop over all the items in the array. So very common, you'll see something like for int I equals 0, I less than list length, list is our array, and we go plus plus, and so then we're checking to see if there are two duplicate strings in our list. So we say line sub I equals line sub I plus 1. The problem here is that we have an error because the index, if list is 1 less than the length, what plus 1 is going to be length, and you cannot access the item at length because we're zero-based indexing. So this will be things that to fix the problem, we need to say length minus 1 because we call I plus 1. So that's something we do. So that's a very important thing, especially with arrays. You gotta be very careful with your indexes, not to go over the end or not to go negative. You know, if I is less than 0, that doesn't make any sense either. So this works for full arrays. So what do we do about partially filled arrays? What if we didn't have, we created an array of 10 items and we only used the first 3? We got to do that. So here's an example of creating a player array called player list. It holds 10 players, but we don't have any in it. So if we access the 0th thing, it is null. So if we tried to say compare the 0th thing to the first thing, we would get a null pointer exception. So player count actually points to the next empty space or the next place we can fill. So if we want to put in a player, we can say player list player count equals new player, and that's fine. And then we increment player count so we know how many players are in there. So now it's 1, and that's cool. What if you want to remove a player without leaving a hole? Because if we say we remove the second player, we don't want to have an empty space there, because if we then said what's the second item, we'll get a null when there might be 3 or 4 because player count might be 10. And we move the second item, player count should actually be 9, but we don't want a gap. We want to actually go from 0 to 8 in our array. So one idea is you take the last guy and you move him into the thing you removed. So here we're taking the last guy and we are going and we're putting it at place K, that's the one we're removing, and then we decrement player count, and that's going to cause that player at player count minus 1, the last guy is actually now in the array twice, but it's okay because player count indicates that that extra guy is not in the filled array. Or we could loop from K plus 1 to player count and shift everybody to the left or up, and then we take the 1 out and we shift everybody, and then we decrement player count. So let's take a look at what that looks like here. So on the left we're going to do the replacement, and on the right we're going to do the shifting. So the first thing is we copy the last guy F to where the case 1 C is, and then we decrement player count. So now you can see where F is in the array twice, but because player count is 5, we only have 5 elements, and we know that that second F is not in the array. It's not usable in the array, and it would be overwritten if we had a new player. So that's how we do it. In the other example, what we do is we copy from K plus 1 into K, and then we copy, and then we copy, and then we decrement. So we still have a double F in there, but the array is actually still in the same order as the first array with just the removed item gone. When we move the last item to the place, we've changed the order of the array. It's much quicker to move the last item, but if you're interested in maintaining the order, you have to do the shifting. So how can we copy an array? You can't use just assignment. So in the example here, we got player A is a new our player array A is a new array of players, player array B equals A, that doesn't copy the array A, it just points B to it. Remember, these arrays are basically like objects, so we're the references to the memory allocation, and so we're just saying B points to the memory allocated that A points to. So there's not two arrays, there's just one array that two variables point to. So we need to create an array, a new array, so we need to say B equals new player array, and we give it the length of A, and then we need to actually copy all the items from A to B, and that will actually do create the array and copy all the elements. So how can we grow an array? If we want to, we've filled up our player array and we want to add an 11th player, what do we need to do? Well, we need to make a new array, copy all the old values into it, assign that copy into the variable that was their original, and then we add the element. So we can see the code where we say if player count is equal to the player list length, so we're full, we create a new array called temp and double its size. So it's going to be twice as big as the old array. Then for all the items, we copy from player list into temp. So now we have a copy and we've got plenty of space in it. And lastly, we assign temp to player list. So now player list now points to temp. What player list used to be pointing to is gone and garbage collected. And then now we can do our addition where we just say player list, so player count equals new player. We increment the player count. So it's just, we have to create a new array, copy the elements over, point our old array at this new array, and then we can add the element. So Java has a very nice class called Java Util Arrays that does a lot of things on arrays that are very, very helpful. You can make a copy of an array by using arrays copy of. You supply it the original array and the length of the copy, so how much do you want to copy, and it will return you a copy. So we could say B equals arrays copy of A.length, which was much easier than doing all that work we did before. The same thing with a player list. We could do player list arrays copy of player list times twice as big, so we can grow it, and we can actually shrink it if we wanted to. And it's making a copy, so it actually does create the new array, copy the elements over, and then returns that pointer. So this does everything we wanted to do in our three-step process. There's also some other array methods that are very helpful. Fill will assign value to every entry in the array. Fill also takes a from and to index, so you could fill parts of the array that go from to to. ToString, which returns a nice string representation with square brackets around each item with commas in between them. And each item basically gets a ToString call on them, so we get a nice string representation of the array. We can sort an array, and it sorts the array into increasing values, so we have the smallest at position 0 and the largest at position size -1, or length -1. Unfortunately, sort only works on primitive types and strings because Java knows how to order primitive types and strings. Of course, it makes no sense to sort Boolean primitives, so it doesn't work with Boolean primitives. Again, we can sort the array, but we can say we want to sort from to, and then we can do a binary search, which searches the array by looking in the middle and deciding, do you go to the left, search the left side, or search the right side. The thing is about the binary search, the array must be sorted because you have to be able to say, is the value less than the middle? And that means all the values to the left of the middle are less than the middle value, and all the items to the right are greater. So it needs to be in a sorted array, but you can call arrays sort before you call arrays binary search. And if the value is not in the array, then you get a -1. The good thing about a binary search is it's very quick because you only search half the list, and then half the list, it's a much quicker sort than searching through every item. One of the problems, though, is it does require a sorted array. If the array is not sorted, then the binary search algorithm doesn't work, and you're probably not going to find the item. So these, the arrays class, you can see how we can grow and potentially shrink these things and copy them, but it'd be really nice if we had a class that had dynamic arrays so that we can add an item, we can remove an item, get a value, set the value, and then get the number of sizes. So we can write a class that wraps an array using the arrays to double or grow this thing, remove an item, we can shift, all that stuff. You saw the examples of how we would do shifting. The problem is we would have to write a class for every type that we wanted to use these dynamic arrays, and that would just be a huge pain. So luckily, Java supplies a class called ArrayList that does it for us, and it's a parameterized type, which means you have the less than and the greater sign, and you say the type. So you're saying, I want an array list of strings. And so that means you can only add strings to this array list strings, or I want an array list of players or player. And so you create a new array list of players. So strings store strings, the strings variable is an array list of strings, and the players variable is an array list of players. You can't stick players into strings, and you can't put strings into players. The type must be a class. It does not work with primitives, and we'll talk a bit about that later. The ArrayList provides a bunch of really useful methods that we just talked about, sort of what things. We can get its size to see how big the current, how many items are in the list. We can add an object to the end of the list, so just add it at the end. We can add it in the middle or at any index. So what we do is we insert the object at index n. Everything else gets shifted to over 1. So if the old object at n is now at n plus 1, we can get a value stored at index n, just like the accessing an array where you say square bracket in the index. We can set the object at index n, which sort of replaces what was there with the new object. We can remove an object at the index n, and again that shifts. When we remove an object at n, everything at n plus or greater than n moves over 1. So the thing that was at n plus 1 is now at n, etc. We can remove an object. So if object's in the array, we can remove that object. It's going to remove the first instance of that object in the array. And we can also ask the question is, what is the index of a particular object? If it's in the array, it'll return the first index of that object. Or if it's not in the array, it's going to return a -1. So you can always say, is this object in the array, and it's at index whatever it is. If it's not in the array, it returns a -1. So all of these things give you an ability to add to the array list, remove, replace things, find out how many there are, find out where they are in the thing. Very helpful class that you use a lot, or in many problems it's almost better to use an array list instead of an array because it's dynamic, it grows automatically, it shrinks automatically, and you don't have to worry about any of that. Java's already done all the work for you. So we talked earlier about that array lists only work with objects, not primitives. So how would we create an array list of ints? We can't call ArrayList int because that's illegal. Int is not an object, it's not a class. So Java provides these wrapper classes for each primitive type. So you just use the capital letter instead of the lowercase level. So capital B byte, capital D double, capital L long, integer, the whole word integer instead of int, capital B boolean. And so you can create an array list of integers, and that would be your equivalent of your int. The other thing is that Java automatically can convert, or does convert, primitives into instances. So when you write integer answer equals 42, 42 is actually an int, it's a primitive, but what Java sees is integer answer equals new integer 42, so it actually constructs an instance of integer with the value 42, and this is called auto-boxing. There's also auto-unboxing that we can, we'll show it down here, we have an array list of integer, ints equals new array list. We can add an integer 42, or we could add the int 42 and Java will automatically box that primitive into an integer. And when we get the first item in the array list, that returns an integer, but Java automatically unboxes it into its primitive type, and so we have the int num. So we can create conceptually an array list of ints, but it's actually an array list of integers, and it's completely transparent to us when we're using it. So that's a quick screencast about dynamic arrays, making them grow, how do we make them grow, and the ArrayList class, which is basically a dynamic, it's Java provides it for us. We can create an array list of any object type, and we can grow the list or shrink the list, and it acts very much like an array, so we can get and set the item at a particular index. Thank you for your attention.